Hello. In the last class, we were doing this particular problem. That is, rotating shaft carries four masses, where you have four planes, and we have started this problem by first drawing the planes representation of four planes and drawing the space diagram, where you have M1, M3 at 90-degree angle, and M2 and M4. You don't know the angles. So theta 2, theta 4 we need to calculate, and here x we need to calculate, okay, and m2 we need to calculate. So for that we drew the tabular column, a representation of plane 1 2 3 4 in the first column, mass, radius, force, distance from the reference plane, where we took second plane as a reference plane, and we return the distance, and finally the couple divided by omega square, that is multiplication of these two columns. We finished till here. So next step here, continuing this problem, now we have to draw the polygons to calculate these unknowns. See here, force column has unknown and couple column has an unknown. So these two things we need to calculate first. So when you have this type of case, first we will start with the couple polygon. So first start with the couple polygon. That means drawing a polygon by taking these values in this particular column related to couple divided by omega square. So you have these three values, minus omega 0.09, 0.1 and 0.14 x. Four values you have. Based on this you have to draw the polygon. Clear? Okay, so first I will start with the plane 1, that is having minus 0.09 as the value. Okay, so we have to enhance this value by taking certain scale. Okay, so we will take a scale of 50:1. Okay, so that means we are multiplying with 50 because the value is very small here. So let me take the scale that is 50:1. Clear? So we will do one by one. So first one is minus 0.09. What is the angle of this first plane? It is having a 0-degree angle. Correct? It is a horizontal line, but you have a negative sign here. Correct? So the direction should be opposite. So take any center point and draw the line in this direction because it is negative. So this is 0.09 is a length OA. Taking the scale 50:1. Okay, that means 0.09 into 50. You have to take and you have to draw the diagram. Next is second plane. The value is 0. So we can't draw anything here. Correct? Because the value is 0. So we'll move to the third one, which is having a length of, having a magnitude of 0.1. What is the angle of this third mass? That is 90-degree. Right? M3 is having a mass of 90-degree from the first first plane. So from this end, draw a line which is equal to the length of 0.1 multiplied with the scale. Angle is 90-degree. So this, from this end, draw a line at angle of theta 3, that is 90-degree. This is having a length of 0.1. So if it was negative, it could have moved in the downward direction. Okay, so it is positive, so it is drawn in the upward direction. Now, as I told in the last class, the polygon has to be closed Okay, so here we have drawn two values. The first and third is drawn. Second one is 0, but remaining now is the fourth one, which is having a value of 0.14x. Correct. So it is understood that the fourth plane has some value, but we have an unknown along with that. Clear? So if we calculate that unknown and we draw the line, it has to close this particular polygon which we are drawing. Okay, so to find out that magnitude, we will just join these endpoints. From B to O, we will join, because it is the position of fourth plane. So we will just join this, the dotted line, in this direction. So it is having a magnitude of 0.14x. Clear? So this is the length of the fourth plane, that is the couple of plane 4. So this 0.14x will be equal to the length OB into the scale. So if you calculate here the value of x, if you solve this, you will get the value of x here. So substitute that value. Okay, so 0.14x. So measure the length, use your scale and measure this length. If you draw the earlier dimensions properly, you will get the proper dimension here. Measure the length OB. I think you will get that around 6.7. OB length you will get around 6.7 in your scale centimeter. Into the scale we took as 50:1, so we have to divide by 50 for this. So calculate x, then just copy, calculate. So x you will get as 0.96 meters, 0.96 meters. So by this we can calculate the value of x here. Now what else we can calculate? We need to calculate the angle of this fourth line, correct? So position. So what we can do is, we have to measure the angle in anti-clockwise direction at the starting point of this line with respect to horizontal. So horizontal, I will just represent that horizontal here from this. So from this line we have to measure the angle up to here. This is the value of theta 4. So measure this angle. So if you measure this angle, I think the theta 4 you will get around 312 degrees with respect to M1. This is the answer, theta 4. I hope you are getting this answer. So this completes the couple polygon here. So first part we have finished now. So we will move to the second polygon, that is couple polygon. So we have to make use of this column now. This column we have to make use to draw the force polygon. So next step is drawing the force polygon. So drawing the force polygon by making use of the force value from the tabular column. Okay, so you have this 0.225, 0.2, 0.14. So these are also the small values which we need to increase, correct? So we can take a scale 50:1 again here, same scale. Okay, so two different diagrams. So there is no condition that both the scale should be same. We can take different scales. So for this diagram I will take a scale of 50:1 is the scale I am taking. Okay, so first we'll draw one by one. Clear? So we'll start with the plane 1, that is 0.225 is the length multiplied with the scale. Okay, and its angle is 0 degree. So take a plane here. I'll draw the diagram on the next page. We need a larger space to draw this. So first is 0.225 is the length given in the positive direction. So first draw that. Okay. So 0.225 in the positive direction multiplied with a scale. So this is 0.225 OA is the line, that is for the first polygon, 0.225. What about the second one? Second plane, again we don't know the angle. Theta 2 we could not calculate till now. So we will leave that as it is. We will move to the third one, that is 0.2. Third plane, which is having a length of 0.2, its angle is again 90 degree. Correct? So from the end, the first line what you have drawn, from that end you have to draw one more line which is having a magnitude of 0.1 and angle is 90 degree. Okay, 0.2 into 50 from this end. So it will go like this. 0.2. Okay, so this is the 90 degree angle you have to maintain with respect to horizontal. So this is the horizontal line. So you have to measure the angle in this direction, that is 90 degrees. So this completes the third plane. So first and third we finished. Now we will move to the fourth one, that is having a length of 0.14, correct? And what is the angle? Angle we just calculated the previous step, that is theta 4 is 312 degrees, correct? So now the diagram where we stop at the end, from this end we have to draw a line which is having an angle of 312 degrees and length is equal to this 0.14 into the scale, that is 50:1. So from this end draw a line at angle of 312 degrees. The angle may look different when you draw, because I am not drawing according to the dimension. So this is having a length of 0.14 and angle is measured in this direction, theta 4, that is 312 degrees. Okay, so we have completed, as I will name this endpoint as C. Okay, so we finished the first, third and fourth, correct? So the system to be balanced, the polygon has to be closed, correct? I told in the last class also. So whatever the remaining part, you can see here from distance between gap between C and O, this gap has to be filled by the second plane now, correct? Only that is remaining. Clear? So if we get that length, we can find the value of M2 here. So just join point C and O. Okay. So like this, just join point C and so that means you are moving from C to O, which is having a length of this value, that is 0.038 M2. 0.038 M2, that is the length of OC. Clear? So this is the line. If you calculate the length of this line, we can calculate the value of M2. Same way how you did for the previous step, calculate this M2. So calculation, so 0.038 M2, which is equal to OC into the scale. So this is 0.038 m2 OC length. For it, measure the length of this OC line using the scale. I think I will get around okay, I don't have the length here written. Fine, calculate the OC length. Multiply the scale 1 by 50. Okay, the length, if you solve this, M2 answer you will get, which is equal to 8.74 kgs. So if you calculate this, 8.74 kg you will get the answer. So this is the value of M2. So measure this OC length using your scale and just substitute in this place. Here you have to substitute, where I put the box here. Substitute the length whatever you get in your diagram. And if you solve, you will get the answer almost near to this. So M2 we calculated. Now if you see the question, we have calculated magnitude of mass M2 is calculated, axial distance we have calculated x value. In this angle between 1 and 4 is calculated, angle between 1 and 2 we need to calculate. So what we can do is, we'll just measure the angle with respect to horizontal. So at this end, where this line started, draw a horizontal line. With respect to this horizontal line, measure the angle theta 2. Use your protractor and measure the value of theta 2. So theta 2, whatever answer you get, that is the angle of mass. I think you will get around 196.5 degrees. This will get around 196.5 degrees. Here, so this is the solution for this particular problem. Okay, this completes this particular problem. Clear?